Good morning. Welcome back to another video on your game. Hoping today to look into our screen resizing issue. So I think I glossed over this in the Flectris series. But if I go run the program, I think I showed this at the end of the last video as well. Everything works right up until you try to resize, and actually coming down looks fine. But what happens as you go up is we just send no information until the screen reaches a stable size. And this was to fix a crash where we were trying to write too many objects to our drawable buffers, and I never took the time to understand it. So we have our fancy new logger set up now. I'm planning to basically just stick some logs in, start poking around. We could use a debugger, but I think this is one of those places where using a debugger would be kind of annoying, because as you're dragging the window, we need to hit the same thing over and over. So I think you'd have to use like a conditional breakpoint or something. Or I think logs, we could just do the simple thing and then go read the logs. And if we need to get into more detail after that, we can use a debugger or something more sophisticated. Alright, so do we have a thing called render frame? Got render frame. So this was my hacky fix, right? Is we have something on our global context, which I think is being set by a callback that we pass to glfw. Yeah, so glfw takes this window size callback, and we sets true on it like that. That's the flags to the renderer to say like, hey, this happened. If the screen resized, we call this handle screen resized function and set drawables count to 0. Else, we call draw drawables and set the drawables count to 0. And draw drawables just copies, or I guess it transforms what we were calling our drawables, which is a array of I don't know how to describe it. Drawables, what are you? These things. So these are kind of I guess the lowest level app idea of what we're going to draw. So it's giving the position, dimension, and depth of quads, which, along with the texture data, needed to draw them. You can imagine if I'm building the game, I kind of want to say, like, what state am I in? Oh, I'm drawing the menu. Oh, I need to draw some buttons. Oh, those buttons are a rectangle here and a load of text. And then the kind of lowest that the app needs to go to then is, well, I'm going to draw a rectangle, and then at a higher depth, so it sits above it, I'm going to draw this letter and this letter and this letter, right? And it fills it in. But the GPU has to go one deeper. So we have these vertex and index buffers. So we're using index draws, which may be pointless. An interesting thought. Just stick a to do in there to think about that. I've got indexed draws. So we're currently using index draws, so we turn that drawable into vertices and indices, and then if we jump back down to our render frame function, which I'm doing the wrong search, render frame, there you go. Puts us in here. So draw drawables takes the drawables buffer, populates those primitives buffers, so this is our just draw the screen. Trying to get my head around why we're doing it like this. Handle screen resized. So the reason that there's some handling to do is all of this swap chain handling. So sorry, let me just have a sip of drink. So we have resources who have to be the same dimensions as the surface we're going to be drawing to make sense. And obviously, as you're changing the screen size, that is no longer true. So what we have is the swap chain, which contains a set of images that we're going to what's the right word? It's the series of images that we're going to write data to tell the screen what it's going to show. And they work best if they are the same size of the screen. I don't actually know what happens if they're not the same size of the screen. Vulkan destroy pipeline. What that's saying. But you can see here, so like we're destroying the swap chain, we're freeing all of our handles on these image resources. Their memory is actually handled by the windowing system, so we don't have to do that. And then down here, we're recreating swap chain, creating the image resources. Yes, my graphics pipeline then also needs replacing, which seems slightly surprising to me at a glance. And our depth image needs replacing. That seems less surprising because the depth image, you'll have seen it in the previous videos when I opened up RenderDoc, we have to have a picture basically that's the same size as the screen that we're writing the depth of the last written pixels to so that we can do depth checking and get ordered draws without having to order the calls. And then we set the flag back to false. So, I think possibly what to do first is to just stick a load of log statements in, right? Go in here and we'll just say handle screen resized gets called at this point. Wait for idle. If it's not success, fail, so expect that to be successful. That'll log, presumably, if it fails, yep. Then what are we doing in here? Handle screen resized. GC window resized. False. Where are you getting called? Just that one place. So this is the advantage. This makes this quite neat. There are spots further in. I'm not remembering. There's points where we can get these errors. So swap chain out of date or suboptimal. Maybe it's worth having a look at what they say about that in the yeah, so there's two spots where it can do it. One is on getting the swap chain images, one on presenting them. It might be worth a quick look in the Vulkan docs to see what they say about that. I can't remember if I have them locally. I think I do. There we go. Can we look for error out of date? There we can't. I think searching everything is a bit slow. Maybe our best bet. Error out of date. Give that a minute. So what are we saying in here? Google Games platform. It's the problem with these docs. They say literally everything about everything. Really, I'm hoping there's a... Oh, maybe I should have looked at the functions instead. Yeah, what was the function I was calling? QPresent KHR. To up to you. There we go. So takes a queue, takes present info, specify parameters. There's no requirement. To present images in the same order they were required. The origin of the native orientation of the surface coordinate system is not specified. The result codes VK error out of date and VK suboptimal have the same meaning when returned by this as they do when returned by that. Oh, okay. So I guess we actually want to go look at acquire next image. HR. So what we're saying in here. Get swap chain images. Down here, acquire next image. Takes a bunch of stuff. If the swap chain has been created with deferred memory allocation, ours is not. If an image is acquired successfully, either that or that, the implementation may return suboptimal if the swap chain no longer matches the surface properties exactly, but can still be used for presentation. Interesting. When does it do it out of date? When successful, VK acquire next image acquires a presentable image from swap chain that an application can use and sets p image index. To the index of that image within the swap chain, presentation engine may not have finished reading from the image at the time it acquired, so the application must use semaphore and or fence to ensure the image layout and content are not modified until the presentation engine reads have completed. Where is, so it's not ready, not timeout. There we go. If the swap chain images no longer match native surface properties, either suboptimal or out of date must be returned. If out of date is returned, no image is acquired. Attempts to present a previously acquired image will also fail with out of date. Applications need to create a new swap chain for the surface to continue presenting if that one is returned. Suboptimal may happen, for example, if the platform surface has been resized, but the platform is able to scale presented images to the new size to produce valid surface updates. It's up to the application to decide whether it prefers to continue using the current swap chain in this state or to recreate the swap chain to better match platform surface properties. Okay, so these two are different. So suboptimal is telling us we can continue presenting. An error out of date KHR is telling us something is broken. We currently don't handle them differently. In both cases, what do we currently do? We log. Excellent. Okay, so we'll be able to see them. I think probably actually let's split that. So if this do a thing, else if res that do a thing. Yeah, we'll go with info. So here, swap chain. It's important it's on present. So present error out of date KHR. This one is present suboptimal KHR. So currently we don't hit either of those, I don't think. And then if it dies, it dies. So what we probably need to do then is say, in this case, skip presentation, and we just drop a frame. And in this case, do presentation, then recreate swap chain. I think that's what we're going to want to do. We then up nya somewhere have the same block. I think I've missed it. Was it error out there's one. Error out of date. There we go. So this will be on getting the image. There's a lot of song and dance around swap chains. I think it's because it's all handled like in coordination with the windowing system. So let's take you, log, info. So this one is on acquire next image. Error out of date. This one is on acquire next image. Suboptimal kjar. So, on that now. And I go drag and close. We should have written a file. I might keep opening a split. Something like log.txt. No. No. Weird. Yeah, Game2 logs.txt. Does it ignore it because it get ignored? I hate that if that's how that works. Game2, yeah. Ignore it get ignored. That's stupid. Right, so what do we have? These going up over time. I don't know what I expect to see. It calls handle screen size resized over and over and over, but it never hits these because we are early exiting out of the function up here. Might be worth a info log in here to say like render frame drawables count equals. I got drawables count equals. What's the thing in Odin talks? It %d. Are these format or are they just? I actually don't know. I think what you do is this. You put it in there. Drawables count. So run the thing, do a resize. Let's go and get these logs. Reread from disk, yes. Okay, so what's the move? We're up here. These go further in time as they go down, do they? Or presumably it pens the end, yeah. So it calls render frame, calls handle screen resized. You can see there, drawables count 6, drawables count 6. That makes sense because we're hard coding. So maybe actually it makes sense if we come back. Currently, our system is very simple. We're hard coding what we're going to draw. Do I have something like push drawable or something like that? That's probably how we actually want to do this. Let's see. It's a bit of a pain to have to do that manually. If I go push drawable, D is a drawable. I think this is what we'll do more realistically, so I think this is worth doing. Push drawable, drawable's this. You go drawables at current drawable count equals D, drawable count plus equals 1. Fix all the obvious and stupid mistakes. Because of course, if we're looking at our actual app, but we don't know each frame how many things we're going to draw, and this number will change a lot as time goes by. So you can imagine as you're typing your name in, we have to draw an extra quad for each letter you now type. So we can't just like draw everything then bang the drawables count. I think what we'll want is something that instead does. How do I do multi-cursor again? Go like this. So all of these together go push drawable. Don't know why the formatting got all screwy there. So they all push drawable, and then we shouldn't need to manually set drawables count. So it works, and we go zip, and we go over to nya, and we open our Game2 logs. We would like that to please yeah, that time doesn't look right, does it? There we go. Reread from disk. What's going on? Okay, I think it updated. So where are we? Called render frame. Ah, it has the location it got called from in there, so I don't need to say what function I'm in. That's kind of neat. Drawables count as 6, and you can see it's stably 6 everywhere. Now I'm hoping if I go back into our renderer and we go find render frame. So the reason we added all of this is if I remove this and this, you should see a drawable count does something silly at some point. Go reopen that, reload the buffer. Doesn't seem to, does it? Okay, given we've got our code locations already, I think it's a good idea to simplify this slightly. Because these things are already big. Let's go grab the logs, reload it. There. Drawables count jumped. Right. Let's see. So handle, screen resized. Do you still want that one? That is our interesting case there, though, right? Is the render frame call comes in. We have 6 drawables. Handled screen resized comes in. It then resets that flag to 0, but nothing has cleared our old drawables, so we just pile more on top of it. And I think what we hit, if I'm remembering right, was that you could do that and get the... You could get so many of these eventually that you'd pop your... you'd pop the buffers. So if we just keep dragging it. So we're drawing so little, I guess it's going to be hard to make it crash, but can we see that number go up significantly? There we go. You see it starts going up. And so it gets reset. It must get reset at a point where it successfully gets the call through. So we just happen to have 2 frames, one after the other, that have a stable size. That's probably actually me turning the mouse around. There's probably like a moment where it's stable for one frame, and then it comes back down. But yeah, you can see here it runs away. So you can imagine this is with just 6 quads, and we're ended up at like 300 odd. It's very, very easy to do this in a stupid way and end up with big problems. But if we don't draw anything in these cases, we also have a problem because it looks terrible. So what do we have to do? Is I kind of wonder if the move is to say, where are we? The render frame should have some consistent behavior where it says, I will get to the end of this frame and I will handle the drawable count. Maybe we always call draw drawables? What does draw drawables actually do? Why will you not jump to that? What's the L, G? Do I have a caps lock on? I might have had caps lock on. Okay. Draw drawables just populates that buffer. It doesn't do anything scary. I guess my thinking was if we are not drawing, we can save that work. But if we're adding complexity, that's probably over a negligible amount of time, right? Like copying 10,000 values, kind of the worst case, isn't actually much work. So I think what we might do is say in here that actually we just always draw drawables. Should draw drawables set drawables count to 0? So I don't think there's a world where we drawables count is 0. Sorry, everything's in one file. I keep thinking it isn't. Because I think that is desirable. Right, we want draw drawables to kind of consume those drawables so that you can't accidentally go to do another draw and have... So this is the other issue. If you have the old data still there, let's imagine you're trying to draw the one thing. You're like dragging it around the screen. It isn't just bad that we're blowing up the amount of data used. We could pop our buffer and crash. It also means that the thing is still there, so you'll draw it over and over and over, and if its position's changing, that won't look right. So I think that makes sense. Can I go ahead and say just here then? So drawn drawables. Say drawables count is drawables count. Might as well also just stick in. We have these for the vertex and we don't count their size though. We just send the whole lot every time. Interesting. Probably using caps lock. I keep forgetting about it. So draw drawables, yada yada yada. Does a load of stuff. Yeah, there is no count for how many vertices. There's a base index. A base index, I think, is just calculated from the drawable, right? Yeah, there you go. So every drawable should generate 4 vertices and 6 indices, and that's how we see that. Cool. Cool, cool, cool. Trying to resist the urge to start thinking about whether or not we even need the indices, but let's not rework that while we're sorting this out. So let's think. So draw drawables has been called. We've cleared our drawables buffer. If we run the program, It's fucked when we make it bigger because the swap chain size doesn't change. So you can see it's fine at small. If we go bigger, it just doesn't know what to do with it. It, I guess, is giving us suboptimal because it is still presenting. It's not like it's blowing up. Let's check that. So I guess let's nip up here. We can see the drawables count over and over. Let's go look for KHR. So we happen to hit it at the right point for it to be an acquire next image suboptimal KHR. First, I think you could hit this. Sorry. Oh. I think you could, in theory, hit this in the like gap between the two. And the first one you see would be a present, but I don't think that matters to what we're doing. And yeah, it gets it suboptimal, suboptimal, and it continues, suboptimal, suboptimal, and it continues. So some operating systems would instead just say out of date, it fails to get the image or it fails to use the image, and it will not be able to draw anything to the screen. I guess you hope all the major desktops handle this reasonably nicely. Okay. What do we do with this information then? So our drawables count isn't blowing up. I think what we might do in that case then is we get rid of that. What does this actually do? We copy our vertex data over and then we zero it out. We copy index data over, we zero it out. So I think this zeroing is how we're handling the the fact that not all of the vertex buffer is actually used. We just blank it all to zero, and then we just act. I think we're still shunting all of the data over, and the amount of data we're moving is just small enough that's not a big deal. Probably bad to be doing it in 2 calls, but even then, actually. Oh. Sorry. Yawned. Lost my track of thought. Ensure previous frame is finished before we start. Waits on this fence. Resets the fence. Here's our first failure point. So, in this case, cannot present. Can present, but should. Can present. Must update swap chain. This is can present, but should update swap chain to make it better. What's all of this in here? Wait result, wait for fences. Right, reset fences. I am kind of on it. So we've kind of got 2 things that we care about, right? It's can we present and do we need to update the swap chain? Even can present, I don't think we matter about too much, right? Because the call to present will just fail. But it will fail with outdated swap chain and be fine. So I wonder if all we do is instead of doing it up front, how do we do this then? Can we have a boolean in here called should recreate swap chain, which is assumed to be false. And then we come down into here. In both of these cases, we just set should recreate swap chain is true. My God. Like that. Else blows up for other reasons that we don't handle. We just crash. We don't come out early. We waste a bit of time essentially. But hopefully a small enough amount of time that doesn't matter. Begin rendering, bind pipeline, yada 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 yada. End recording command buffer, submit commands, and then present image is the same. So if we get back the result suboptimal KHR, I think it has presented the image, but it's just telling us that the swap chain isn't good. So can we say in here, should recreate swap chain is true. And in here, should recreate swap chain is true. Then down here, if it should recreate swap chain, we recreate the swap chain. Do we have a single function that does that? I thought we did. Hoping it's literally called recreate. No. Bugger. What were we doing? What were we doing before? Down here somewhere. Handle screen resized. Takes a renderer, and what does that actually do? It currently logs. And I mean, what does this then mean? I think our window resized handling is not needed, I think. We're not using it. We're not doing this proactively. We're just relying on what the Vulkan API gives us back. And that sets a load of stuff on renderer. No? Your problem. Cannot take pointer address. Are you already pointed to renderer? You are. Okay, cool. Right, so we do that. You can see it sort of stutters a bit as it comes up. If I drag it quickly, that might not show very well on the video. I think, though, that... Oh, hang on. Pop you out of that mode. Right, so drag it around. Yeah, you see, I can, if I drag it quickly, I can make it sort of stutter. So it's still not ideal, but I think that's better at least. And I guess it's simplified the world as well. Like I say, we're doing a load of work that's maybe not necessary all the time. We're not being particularly careful about our There are cases where we could exit out earlier, and we're not doing so. I don't think it's going to tell us much. Ah, there we go. And the screen resized has reset the value to 0. Ah, okay, my logging's still in there. That's not useful. So what was it? Handle screen resized. Logs when it gets called, and then down here we were saying it's set I think to 0. It's not doing that anymore, so we can get rid of you. So I think if we go back to main, I don't think anything else is using this window size callback. Is it worth putting our logger on that? I'm curious. How do we do it though? Because we don't pass it the thing there. The default context will get us like the default logger, obviously. Would I have to pass a logger on this? Logger, what's the type on logger? No idea. Where are we looking? We're in here. Stick it on global context, just everyone can grab it if they need it. So my logger, what type do you need to be? Runtime.logger. Why won't you reformat? Manually stick you over there then. gc.logger is equal to log.create multi logger out of file logger and console logger. Then context.logger is our global logger, and that's useful to do because now this bad boy doesn't need to be passed in because it's global. Let's say context dot logger equals gc.logger, and you, instead of doing this, I can just log info glfw window resize. File logger. Interesting. Pop you there. Now, knit. And then another one. Let's go. Game2 logs. Read you in. Might even be worth taking out our thingy there, but we just do a bit of scrolling. There you go. You can see there's window resize detected, another window resize detected because it's a callback that's firing on GLFW's terms, not on ours. So I guess they managed to fire it twice before we render another frame. Then acquire next image, suboptimal KHR, presents suboptimal KHR. It then handles the screen resize, and then it's just fine for a while. Detects the next one. Yeah. Okay, I think that's looking healthier than it did before. I think that'll do us for now. So, not the longest video in the world, but I don't know. Hopefully that was interesting. I've been doing that off for a little while because I didn't want to have to sit stepping around things. Might be worth us taking out the logging on every frame. I think is a bit noisy at the minute. I know I was saying, so the point of adding this logging to file is my info logging can be noisy because I won't be seeing it all the time. So this is the intention. Like, you can imagine if it was hard to see when these things happened, I could have made the states in here log error. Actually, we do this. We go in here, log error, and up here, log info, blah. Then we watched this, and let's imagine I didn't know that I had an issue with these things, and that this wasn't a state I expected to hit. And I drag this, you go, oh, something is happening. But it's only telling me there's something I care about. And then I can go from there to my game logs, and I can see all of my info logging, and then down here, my error logging somewhere. There you go. And this tells you the actual picture, right? If I didn't know what was causing these, I could come in here, I could then see, okay, GLFW is getting a window resize, and then I hit errors around my render frame, acquire next image, suboptimal KHR. Those two bits of information together are useful to me now. But seeing this every time it happens is not useful to me because it should be happening. It would drown out all these error messages. So like I say, I don't know if the performance cost of doing that is so great that we don't want to do it. That might be the case, but at this stage, I think that's useful. But I think our drawables zeroing out the drawables count every time means that isn't really an interesting piece of information anymore. That was very, very specific to how it behaved before. These don't want to be errors. These probably want to be... Should they be worn that you could grab them easily? Because they are unusual, right? Warn or warning? Yeah, so... I think it may be useful to make them worn. And down here, I'll make the other ones worn. Wherever they were. Present images. Look at that. And then we'll put an info log in here to say recreated swap chain. I think I also then want to go back into main.odin. I'm going to make that into a warn. I think I want my console logger to only fire on error. I think it's useful to get those warnings because if I then know there's a problem, I might come in here and make that less strict, but I don't really want it warning me on stuff that's, I don't know. I feel like warning is for something that's not a error per se, like it will happen, and it doesn't mean that something's broken, but it is not the kind of expected normal path. I think this is not the expected normal path. Like most of the time, we should be sat at a single screen size, just chugging through frames. So this is a behavior we should handle, but it's kind of notable as a potential edge case that could break, and indeed has broken in the past. Right. I think that might be us done for that issue. What do we think about this question? Or we just commit it and forget about it? So how this works is vertices are like a data structure that we pass around. So if we come in here and say vertex, no, do I not have a vertex file? Yeah, vertex. So we've got our drawable that says I want to draw a quad at this position with these dimensions using this texture. The vertex says that each corner of that quad, we have to define this, but actually it's more than that. It's for every corner of the triangles that will actually be our rendering primitive. So every quad is made out of two primitives. So what you could do is you could send 6 vertices and we'll have 2 repeated, right? You can imagine if we've got, I don't know if, one of those things, I don't know if I'm over explaining now or if this is useful, but is this working? It's not working. I've not run. I have a setup script to make this page like I want it to. So we're drawing a quad. Actually, what we're drawing is 2 triangles, and we have 4 corners, A, B, C, and D, and I can't remember which ways are forward winding, but let's say our forward winding is anti-clockwise. So for this to be facing forwards, we would have D, B, A as one triangle, right? And D, C, B as the other triangle. So what we could do is we just send over 6 vertices. And we'd send like DBA and DBC. And each of those, in our case, we can be very specific about this. Each of those is Vec3, which means it's 3 F32s. So each of these is 4 bytes. So that's 12 bytes plus 16 bytes plus 8 bytes. So 12 plus 8 is 20, 36, 40 bytes. You send over 6 of them. That's 240 bytes. If we do an index draw, what you actually do is you'd send over 4 vertices. Right, we send each vertex once. That's D, B, A, and C. We send them all. I don't know why I've done them in that order. In this point, we can just do A, B, C, D. So the order we put these in doesn't matter. And that's 1, 2, 3, 4. Save some room, I think. Or at least this is the logic. You save room. So 240 bytes is 40 bytes each. That's 160 bytes. Excuse me if I've done these numbers wrong, because doing maths on the fly is always risky. But I think even if the numbers are wrong, the point is still true. So it means that there's less data being sent in vertices, but we still then need to communicate the ordering of these things. So then you'd send across, I think it's 6 indices. If we come and have a look, so our vertex buffer is using this vertex data structure. Our index buffer is sending U32. So each value in there is only 4 bytes. We're sending 6 of them. So 4 times 6 is 24 bytes. So even in this really simple case, these two sum to 184 bytes. So it's more space efficient on the GPU to use indices instead of vertices, even in our really simple case. This gets more silly if you start looking at like 3D. And this is why I was saying I don't know if we benefit from this really. Is I think if you're doing 3D, you can imagine you'd have this quad, but then you'd also be sending another quad next to it. That because it's 3D, it's not in a single plane, right? It's kind of kipped backwards. Oops, wrong button. So in our case, we're drawing a quad. We're going to reference a texture that pulls off a sprite sheet and just draws to that quad. In a 3D game, you can imagine that we might have several quads next to each other that are all sampling off the same texture because they all have the same fur or whatever. They're going to go through the same set of steps, but because they're all at different angles, they're going to get different lighting and different effects on them. So they all end up looking quite different, but it's the same texture stretched across them. And it still has to be broken down into multiple smaller primitives to handle the shape more sensibly, right? But that means that actually the number of vertices, so the size of your vertex is probably bigger because you're going to be sending more data across, and the number of these vertices that are shared is increasing. Now, it's not just these two that are internally shared, but these two are now shared across multiple instances. So you'd save a lot more space in 3D stuff, I think. But we're not doing 3D stuff, so you can see even in our simple case, I think it saves you some space. And the way that this would then work, instead of this vertex buffer communicating the ordering, we would then go in here. So let's say this is all in here. This is 0, 1, 2, and 3. So there are indices into that vertex buffer. We would say, what did I say before? So DBA. So D is 3, B is 1, and A is 0, 3, 1, 0. And then DBC, it would be 3, 1, 2. All right, and they're the numbers that we would write into our index buffer. All to say, I think we gain, but very, very marginally. I guess the cost is that we now have to do 2 separate mem copies instead of just the one, which probably loses some sort of cache efficiency. But currently, I'm leaning towards nobody cares. I guess what I wanted to check is I didn't think this. If we looked at this and it was actually costing us, and we were taking more steps to do it, I think we might have stopped to get rid of it. it'll be quite an easy simplification, right? You would just take that out and you'd update draw. We looked at it earlier. What was it called? It was drawables in YAR. So it currently has to populate both of these things. So vertex buffer gets its 4 vertices, you can see there. And then we write just numbers into the index buffer, and there's 6 of them. So you would just take this out, and there would be some duplicating in the vertex buffer. That might just be interesting to try at some point if it does affect the performance at all. Maybe one to do after we get the profiling stuff set up. I'm slightly surprised that it's not letting me. Okay, it's letting me now. Right, so save that. We're just going to format these files because I saw a load of unneeded white space in the diff just there. What is main doing? We've got our global context logger so that everyone can grab it to put it on C functions if they need to, which I think sounds fine. We've added push drawable, which I think makes sense. Using the context logger on our C function. And then there's all these changes. What are your problems? You just formatted. Yeah, I knew it was a bit of formatting needed. That should be moved into drawable. Yeah, there's going to be loads of formatting. Okay, screw it. I think we're fine. It runs. That's the actual meaningful check, right? We drag that out. Like, that's behaving more nicely. I don't know if you can do anything about this where I don't know if that's communicated very well in the video. If I drag this open and make it bigger quickly, you can see it kind of stutters and struggles to keep up. I don't know what we could do about that, though. All right, let's call that then. Fix bad screen size handling in frame render. Cool. And I think we had a thing in our readme. Let's go readme. Make that nicer. It's done. Can render be made nicer using more dynamic rendering? No. Yeah, so it's memory usage and profiler stuff, I think. Maybe it'll be interesting once that's set up to go and look at, I guess, our frame times and convert to just using a vertex buffer and see if it improves things. But even then, we probably need a more realistic workload than our little toy situation. That might be something to leave for quite a while. All interesting. It's the problem with doing these things. There's so much interesting stuff to do. And I know it's not my job. So you don't actually get that much time to play with these things. But we enjoy the time we have. I hope you've enjoyed that. I've had fun. I will catch you on the next one. See you later.